I've taken up another problem, a problem similar to the one which I've already done with an independent source. I'll post the link of that video in the description box so that you can see that video first, then you can look into this. However, I would suggest the learners to have a copy before them, then write down this problem, then solve the problem on their own, and later see the video. That would help them learn things properly. All right, so having said that, let us go ahead with this problem. We are supposed to find V1 and V2 in this problem along with the power delivered to 16 ohm resistance. So how do we look at this problem? This problem has got two independent current sources and there is one voltage source which is dependent voltage source, and we can easily see that it is a current dependent voltage source. So this voltage source has got a resistance across it which doesn't have any role to play. So as far as the source is concerned, the 16 ohms, the magnitude of the 16 ohms doesn't matter whether you have 16 ohms or whether you have infinite ohms or whether you have any amount of resistance across it, it doesn't have any role to play as far as the various other responses in the parts of the circuit is concerned. Right, so we can even replace this resistance by an open circuit and go ahead with the problem for better way of doing it. Okay, so let's try to look at this problem. I will copy this problem, then let's try to approach this problem by different methods. Okay, so I told you I have done a similar problem with independent sources. Like instead of 5ix, which is a dependent source, I have done it with an independent voltage source. So you can have a look at that. But then there again I have worked the same problem with 3 methods. Here also we will try to do it by 2 simple methods. Then the third method I would leave it to the viewers to do. So what I mean is I can get rid of the 16 ohms directly. So my problem becomes this much now. Okay. So 16 ohms is present. It is not that 16 ohms is not present. 16 ohms is very much a part of the network. As far as the power dissipation is concerned, it will have power dissipation in it. But however, it doesn't have any role to play as far as the currents and the voltages in other parts of the circuits are concerned. Right? So we will try to approach this problem. Method 1. First method, let's have the node voltage method. Node voltage method relies on the understanding of KCL, Kirchhoff's current law. All right. So we need to know the currents in various branches of the network. Then we need to identify the junctions or the nodes. Then we may have to consider one reference node, and we may have to talk about the potentials of the other nodes with respect to that particular reference. We identify 3 nodes in the problem. There is a node which has been identified. The problem itself has got a potential of V1, and this is V2, and let me tell you, in the problem itself, this was given. This has been given in the problem itself. That is when you can identify V1 and V2. Otherwise, you cannot name them V1, V2 unless you have some reference potential, right? So this is our reference potential, and V1 and V2 have been marked. So in order to apply KCL, we need to know the currents in various branches. Okay, so if I look at the node V1, okay, so the branches that are meeting, there is a current source, 10 ohm resistance, and there is a voltage source. 5 ampere current source is pumping out current 5 amperes into the node. Ix is the current that flows out of the node V1 through 10 ohm. What is the current in this branch? We don't know the current in this branch, right? So this particular voltage source simply maintains 5x potential difference between V1 and V2. We do not know the current here. So in order to avoid this branch, so what we do is we try to consider V1 and V2 as one super node. Okay, one super node, and apply KCL. Like we assume a current to be in this direction, in this branch. And this 33 ohm is again pumping current in. So we will now apply KCL to the super node. So what's a super node? And identify the super node to be this entire thing is a super node. This is what we define as a super node. This is my super node. Okay, we'll try to apply KCL to the super node. Okay, writing KCL equation to the super node. We get, what is it we get? We will write the equation, and this is, I'll write V1 divided by 10 is the current that leaves the terminal. Okay, and to the V2, it is V2 divided by 20, that again current leaving the terminal. Current entering V1 is 5 ampere, and current entering the node whose potential is V2 is 3 ampere. Okay, this is one equation I get. So I'll simplify this equation. This comes out to be 0.1 V1 plus 0.05 V2 equal to 8. Equation 1. Alright, so we have got one equation in V1 and V2. So we need one more equation in V1 and V2 because we have two unknowns, right? And it's very evident that from the super node, if I look at the super node V1 and V2, they are maintained at 5 times Ix. That is a voltage magnitude, right? So we can easily write V1 minus V2. The potential difference between node V1 and V2 is 5 times Ix. Okay, but what is Ix? We have introduced one more unknown, right? Ix, we don't know what is Ix. Ix can be expressed in terms of V1. If I can see what is Ix, Ix is V1 divided by 10. So this is 5 times V1 divided by 10. Okay, how did I get that? Because Ix is the potential difference across 10 ohm, that is V1 minus 0 divided by 10. Okay, so V1, the potential of this node, 0. V1 minus 0 is the potential difference, turn ohm is the resistance. V1 divided by 0 by 10 is the current through 10, right? That is the logic. So if I simplify this equation, what I get is, this is 5 2s are, that is 0.5 V1 on the right hand side. When it comes to the left hand side, it comes out to be 0.5 V1 minus V2 equal to 0. This is my equation 2. Simple, primary school children will be able to solve this equation 1 and 2, right? You have two equations and two unknowns. We will solve. You have calculators. Solve for V1 and V2 from 1 and 2. Okay, two equations and two unknowns. You use calculator, use Cramer's rule, you use substitution method. Whichever method you do, you can solve for V1 and V2. I will not go into the elaborate calculation. So I will get this to be 64 volts. And you will get V2 to be 32 volts. Okay. These are the values. And what is Ix? I can even get Ix as V1 divided by 10. So obviously Ix is 6.4 ampere. Alright, so I'm able to get all the three values. So having found V1 and V2, we can find out what is the power that gets dissipated in 16 ohms. How do we do that? Power in 16 ohms is voltage across 16 ohms divided by voltage across 16 ohms square divided by 16 ohms. V square by R. What is the voltage across 16 ohms? It is V1 minus V2 whole square divided by 16. This is 64 minus 32 whole square divided by 16. Or it is simply 5 times Ix divided by 16. 5 times Ix square divided by 16. This you will get it to be 64 watts. So power in 16 ohms is 64 watts. That completes the problem by nodal method. Okay, these are the things that we needed to determine. We need to find out what is this. And we need to find out what is this. Okay, so we are done with this. This is one method. Okay, we will try to approach the same problem by mesh current analysis method and see how that comes out to be. Okay, method 2. Mesh current method analysis. What is the basis for mesh current analysis? It's KVL. Okay, that's the basis. So what I do is I'll pick up the network. Rather the modified network, I'll try to take this network, I'll try to copy. I'll copy the network, paste it here. Okay, I'll remove the nodes now. What I mean is the super node part I'll remove. I'll remove this also. Of course, I need IX. Okay, so this is my network now. How many meshes are seen? Having done these problems repeatedly, we can easily identify the meshes. A mesh is a smallest part of the smallest closed path of a network. So if I look at this network, I can identify a mesh here, and there's a third mesh. Okay, so if I have a current source in a mesh, so we know by now that the current in that particular mesh is nothing but the current source magnitude. Rather, the 5x would circulate in this mesh. Okay, so rather 5 ampere would circulate in this mesh, and I'm going as per the direction of flow of the current source, right? It is a clockwise current, so I'm taking 5 to be clockwise. So in this mesh, rather in the mesh having 3 ampere, a 3 ampere current would circulate in this mesh. I'll take 3. I'm going as per the direction of the current source itself. Okay, so now in the third mesh, I will assume an unknown current. This is an unknown current of I amperes. All right, so I will now write a mesh equation. We need to solve for I, then we will get the result. Okay, so as usual, I'll stop from the top left corner V1, go via the voltage source along 20 ohm, along 10 ohm, come back to V1. Okay, how will that be? It's going to be from V1 to V2, the potential difference, right? I'm supposed to take the potential difference across each branch because it is KVL. So the potential difference is 5 times Ix, drop in potential, plus 20 ohm resistance multiplied by, what is the clockwise current? Clockwise current now is I plus 3 because both are flowing from top to bottom. So as far as 20 ohm is concerned, this is my 20. Here is in this mesh it is I, in this mesh it is 3. So the total current in the branch is I plus 3. Alright, so I've come back to 10 ohm. This is 10 into the clockwise current now is I minus 5. I suppose you need to appreciate this clearly. This is 10 ohm. So here it is I, that is clockwise, and here it is 5. So the current here in the upward direction is I minus 5. Okay, this trivia you need to know. This is equal to 0. Alright, so we're able to write the equation. Now what is it we need to do is remove Ix. There is one more unknown that got introduced, right? So what is Ix? It is simple. Ix is nothing but the current in the 10 ohm branch, right? So that in terms of I, we can write Ix to be equal to, so you can see Ix is in the downward direction. This is Ix. Okay, this is direct. What I mean is, this is Ix. So in the downward direction, if I have to write, this is 5. This is I. So Ix is obviously in the downward direction. It is 5 minus I. Okay, so you may have to be careful here. So I will replace Ix by 5 minus I plus 20 I plus 60 plus 10 I minus 50 equal to 0. I will have to simplify this. This is 25. Everything you will do, you will simplify this to be 25I plus 35 equal to 0. Rather, I equal to minus 35 by 25. That is minus 1.4 ampere. Okay, that is the current. Okay, having found the current, we can always find out what is 5 times Ix, right? So why are we interested in 5 times Ix? Because we need to know this voltage or the potential difference, or V1 minus V2, so that we can find out what is the power that is consumed in 16 ohm resistance, right? So in 16 ohm resistance, we will have to compute the power consumed, right? So we will directly do what is V1 and V2. What is V1? Having found I, we'll first find out what is V1. Okay, so V1 is the potential difference across 10 ohm resistance, right? This 10 ohm resistance is what gives me the potential difference, V1 minus 0, right? So potential difference across 10 ohm is V1. So that is 10 times the current through it. Okay, so this is what is the current through it? Current through it is Ix, right? This is 10 into Ix. But what is Ix? What is Ix? Ix equal to, we can determine what is Ix equal to 5 minus I, right? So I will write 10 into, this is 5 minus I. We have done it here. Ix equal to 5 minus I. Okay, that substitution I have done. So this comes out to be 10 times 5 minus of minus 1.4. This comes out to be V1 equal to 64 volts. Okay, all right. So in fact, Ix comes out to be 6.4 ampere. Okay, Ix comes out to be 6.4 amperes. 10 times 6.4 amperes is 64 volt. Similarly, we will determine what is V2. What is V2? Is the potential drop across 20 ohm resistance. This is 20 times the current through it in the downward direction. That is I plus 3. I we have determined, right? So we will substitute 20 into minus 1.4 plus 3. That will come to 32 volt. This is what we have done previously by nodal method. So what is the power? Power in 16 ohm is V1 minus V2 is the potential difference whole square divided by 16. This is eventually also equal to 5 times Ix whole square divided by 16. You do by any method. Substitution, you will get it to be 64 watts. Okay, and that completes the problem. What have we found? We found V1 to be 64 volt, V2 to be 32 volts, and power in 16 ohm is 64 watts. So these are the two methods I thought I would take up in this video. For the third method, that is solving the network by superposition theorem, because you have got 3 sources, you can always apply superposition theorem and find out. You can do the same problem using the third method. All right, I suppose this is clear. I would expect students to, take up a pen and a paper, do it on their own, then watch the video. All right, so any difficulty you have, any problem you have, you can always comment, post, and I would appreciate. Okay, if you have any difficulty, you can even post the problems, which I'll be too happy to take up. Okay, thanks for watching. See you in my next video, which I intend making on 2-port networks.